And we're going to write those steps off to the side again for solving radical equations. Okay? 1. We're going to isolate the radical. Okay, I'm going to put in here mixed radicals are okay. Because in our first example, we have a mixed radical. That's okay to keep by itself on one side. After we isolate the radical, we're going to square both sides. Both of these green steps are new for us because we haven't solved radical equations before. Once we square both sides, we're going to get something we have done before. So I'll put it in blue here. We're going to solve for x because that's something we've done before. But then another new step for all radical equations is that you have to verify. So there's 3 things that are new, and then the blue part just builds on what you've done before. So for A, is the radical all by itself, or mixed radical all by itself on one side? Yes. On the one side, we have a square root. There's no adding numbers after it. There's no subtracting numbers. We've got just a mixed radical all by itself on the right side. So we can start by squaring both sides. Now, when we square the right side, remember squaring is multiplying by itself. Now, 3 times 3 is just going to be 9. What happens when you have 4 root x times 4 root x? Again, sometimes it helps to write it out. How do we multiply radicals? We multiply the numbers. So it'll be 16. And root x times root x will be root x squared, which will just be x. Because root x squared, that would cancel it out. Again, remember at the beginning of this unit, we sometimes put absolute value bars. I'm not going to worry about that. We'll just call it x. We won't add the absolute value bars and worry about where it's defined and where it's not. When we're solving, this verification thing helps us with that. Now, how would I solve for x? Divide both sides by 16. And I get x equals 9 over 16. Now, we have to verify. The way that we verify, write out the word verify. Write your left side of your equation, draw a line, write your right side of your equation. On the left side of the equation, right at the beginning, we started with 3. On the right side of the equation, we started with 4 square root of x, and x we write 9 over 16. So we're going to have to do some mental math, some solving here, some evaluating. You know that square root of 9 over 16 is the same as square root of 9 over square root of 16, and 4 is like 4 over 1. On the top, I would have 4 times 3. On the bottom, I'd have 1 times 4. Maybe you can see that the 4s would simplify, and we get 3. So we have verified, check mark. Since the left side equals the right side, this is the real answer. It's not a fake answer. Our second example here is our radical isolated? No. So we would need to add 7 to both sides to get our radical by itself. That will give me 20 equals 2 root x plus 1. It's okay to have a mixed radical all by itself. I left the last question as a mixed radical all by itself. Sometimes, if you look at this, can you see that you could easily divide both sides by 2? Last time I didn't divide by 4 because it would give me a fraction and I didn't want a fraction. But this time I could easily divide both sides by 2. And then I would have just the radical, not a mixed radical by itself. So we have isolated the radical. I simplified it a little bit more than last time. And now when I square both sides, ten squared is 100. Squaring a square root, those are opposites. All that'll be left is x plus 1. Subtract 1 on both sides. You get 99. We still have to verify to see if that's actually a right answer. We haven't got any spies yet. They're not actually called spies. The actual word is called extraneous roots. Spies sounds a little cooler. We're going to verify here. Our left side started with 13. Our right side started with 2 root, then minus 7 at the end. And we had 99 plus 1 inside the root. (99 plus 1 would be 100. Square root of 100 is 10. 20 minus 7 is 13. And this is a real root. Questions you can do? 4, 5, and 6.